myself, Henasha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of multiple integrals. So let us begin with the topic named change of variables from Cartesian to polar coordinates. Okay, so the double integral can be changed from Cartesian coordinates x, y to polar coordinates r, theta by putting x is equals to r cos theta and y is equals to r sin theta. Then double integral f of x, y dx dy equals to, you have to replace x by r cos theta and y by what? R sin theta. So this will be equals to double integral f of r cos theta, r sin theta, mod j dr d theta. Whenever we change the variables, right, then we have to find the Jacobian, right? So where our Jacobian j is equals to del of x, y upon del of r, theta, which can be written as determinant of del x by del r, del x by del theta, del y by del r, del y by del theta. Okay, so now let us find the Jacobian, right? So here we have to partially differentiate x, that is our r cos theta with respect to r, right? So we have to keep theta as constant. So this term will remain constant, right? Now if you find the derivative of r, it will be equals to 1. So what will remain? Cos theta. Okay. Next you have to find the derivative of x with respect to theta. So what you have to keep constant? R as constant, right? So the derivative of cos theta will be what? Minus sin theta, right? So the answer will be minus r sin theta. Similarly, we will find the derivative of y with respect to r, keeping theta as constant. Therefore, your sin theta will remain constant. Now the derivative of r will be what? 1, right? So the answer of del y by del r will be sin theta. And lastly, find partial derivative of y with respect to theta. So this r will remain as it is, that means constant. So what will be the answer of the derivative of sin theta? Cos theta. So the derivative of del y by del theta will be equals to r cos theta, right? Now we have to solve this determinant, right? So what will be the answer? R times cos square theta plus sin square theta. But we know cos square plus sin square is equals to 1. Therefore, our Jacobian will be equals to what? R. Now let us put this value of j in this, right? So finally our double integral f of x, y dx dy will be equals to double integral f of r cos theta, r sin theta, r dr d theta. What we have done here in all, we have converted this xy to r and theta by putting x is equals to r cos theta, y is equals to r sin theta. In such type of questions, always our Jacobian, that is our mod j, right, will be r only. So your dx dy will be equals to what? R dr d theta, always, right? So now let us solve one example. So here we have to evaluate double integration 0 to a, 0 to square root a square minus x square plus y square dy dx by changing into polar coordinates, right? So here we have to compulsory change our given question into r and theta form, right? So let us start with the solution. So firstly, we will write our given limit. So from this you can see that our limits of x are what? 0 to a, right? Therefore, x varies from x is equal to 0 to x is equal to a. Now our limits of y, right, are 0 to square root a square minus x square, right? So our y varies from y is equals to 0 to y is equals to square root a square minus x square. Now let us simplify this, right? So take the square root on this side. So what you will get? Y square is equals to a square minus x square. Now take this x square on this side, so you will get finally your equation as x square plus y square is equals to a square, right? This is your final equation derived from this limit, right? Now we'll compare with x minus h whole square plus y minus k whole square is equals to r square. This is our general equation of circle, right? So on comparing, what you will get, our center of the circle h comma k as 0 0 means origin, and our radius as r is equals to a, right? So this is a circle with center as origin, right, and radius as r is equals to a. Okay, so now let us draw our graph from the given limits. So here x varies from 0 to a, right? So from this we can see that our circle is only in the first quadrant. Okay, so we have to consider only the circle in the first quadrant only. And our y varies from y is equals to 0 to y is equals to square root a square minus x square. So this is our vertical strip which starts from y is equals to 0, that means x-axis, and this is our given circle, right? So to our circle y is equals to square root a square minus x square, right? And in polar coordinates, again we have to draw a circle in the first quadrant, but here the limits of theta will be from 0 to pi by 2 in the first quadrant, right? And we have derived that r varies from 0 to r is equals to a, right? So from this diagram we can see that in polar coordinates the limits of r will be from r is equals to 0 to r is equals to a, and the limits of theta are 0 to pi by 2. Okay, so now let us change our given question in the polar form. So what is your question? I is equals to double integration from 0 to a, 0 to square root a square minus x square plus y square dx dy, right? Now let us replace the limits and dx dy by what? R dr d theta. So your limits of theta are 0 to pi by 2, limits of r are 0 to a. Now we have derived already that x square plus y square is equals to what? R square. How we can prove this? X is equals to r cos theta, right? And y is equals to r sin theta. Therefore, x square plus y square will be what? R square times cos square plus sin square theta, right? Now this is 1. Therefore, we can say that x square plus y square is equals to what? R square. So the value of this is r square, right? And dx dy is r dr d theta. So now this will be equals to what? R cube, right? And now we'll integrate this with respect to r first, keeping theta as constant, right? So now our integral will be equals to integration from 0 to pi by 2 and integrate this with respect to r. So you will get r raised to 4 upon 4 and the limits are 0 to a d theta. Now let us put the limits in place of r. So what you will get? A raised to 4 upon 4. So keep that outside as it is constant, and now integration 0 to pi by 2 d theta will remain. Now we know the integration of 1 d theta will be equals to what? Theta, and your limits are 0 to pi by 2. Okay, now again let us put the limits. So what will we get? Only pi by 2, right, in place of theta. So the answer on simplification will be pi a raised to 4 upon 8. Okay, so firstly we have to put x as r cos theta, y as r sin theta, and dx dy as what? R dr d theta. Okay, then we have to find the limits with respect to r and theta and evaluate our given integral, right? So let us solve one more example. So we have to evaluate double integration from 0 to a, y to a, x upon x square plus y square dx dy by transforming into polar coordinates, right? So again we have to transform the given integral into polar coordinates, right? Let us start with the solution. So here our limits of x are what? y to a. Therefore, our x varies from x is equals to y to x is equals to a. Right? Now, our limits of y are 0 to a. So, our y varies from y is equals to 0 to y is equals to a. Right? Now, let us take our assumptions, that is x is equals to r cos theta, y is equals to r sin theta, to convert it into polar form, right? So now let us find the limits. Now we'll consider the given line as y is equals to x, right? Now let us put these assumptions. Therefore, y is equals to what? R sin theta, and x is r cos theta. So from this, what will you get? R will get cancelled. Sin theta upon cos theta will be what? Tan theta. So tan theta is equals to 1. So finally the answer of theta will be what? Pi by 4. Okay, so this is our first limit of theta. Now let us consider line x is equals to a. So what will we get? R cos theta is equals to a. Now cos theta will take on this side, right? So what will we get? R is equals to a sec theta. Okay. Now let us draw our graph. So here x varies from x is equals to y to x is equals to a. So firstly let us draw the line x is equals to y. So this is our line x is equals to y. Now let us draw our line x is equals to a. So this is our line x is equals to a. Now let us find the point of intersection between the line x is equals to y and x is equals to a. Okay, so we are given x is equals to y and x is equals to a. So from these two, what we can say? Y is equals to also a. Therefore, our point of intersection is a comma a. So this is our point of intersection, right? Now draw the line y is equals to 0, but this is our x-axis. Okay. Lastly, y is equals to a is considered in this point. Right. Now we are given our strip as a horizontal strip, that is from x is equals to y to x is equals to a. Okay. So similarly, draw the triangle in the polar coordinates. Right. Now we have already found out the limit of theta, that is our line theta is equals to pi by 4 and r is equals to what? A sec theta. Okay, so now firstly draw the line theta is equals to pi by 4 in our plane r theta. Now here you can see theta is equals to 0. Here what will come? Theta is equals to pi by 2. So where we can draw our line theta is equal to pi by 4, it will be in between theta is equals to 0 and theta is equals to pi by 2, right? So this is our line theta equals to pi by 4. Okay, so our theta moves from 0 to pi by 4, right? In our region R, right? So this is the limit of theta, that is 0 to pi by 4. Now our radius R varies from r is equals to 0 to r is equals to what? A sec theta. So the limits of r is equals to 0 to r is equals to what? A sec theta. Right? So now let us convert our given integral, which is given as I is equals to double integration 0 to a y to a x upon x square plus y square dx dy. Okay, so now let us give a change into the limits and our given function. Firstly, our limits of r are 0 to a sec theta and the limits of theta are 0 to pi by 4, right? Now we have assumed x as what? R cos theta, y as what? R sin theta. Therefore, again our x square plus y square will be what? R square times cos square theta plus sin square theta, right? Therefore, our x square plus y square will be what? R square, right? Then our dx dy is equals to what? R dr d theta, right? So let us put all these values over here. So x is equals to what? R cos theta. Then x square plus y square is equals to what? R square. Dx dy is equals to what? R dr d theta, right? Now these two r will get cancelled out. So finally, what will remain? Double integration from 0 to pi by 4, 0 to a sec theta, cos theta dr d theta, right? So firstly we will integrate with respect to r, keeping theta as constant, right? So our cos theta will remain as it is, and integration 1 dr will be what? R, and your limits are 0 to a sec theta, right? Now let us put the limit in place of r. So whenever you replace this in place of r, you will get a sec theta, right? And whenever you replace r by 0, the answer will be 0. But we know sec theta into cos theta will give us answer as what? 1, right? So finally what will remain? Integration 0 to pi by 4 d theta. Take this a outside. Now integration 1 d theta will be what? Theta, right? So finally we will get a times theta, and the limits are 0 to pi by 4. Okay, so now let us put the limits in place of theta. So whenever you replace the limit, you will get a times pi by 4 minus the lower limit, that is 0. So the final answer is what? Pi by 4 times a. Okay. So in today's session, we have studied changing into polar coordinates, right? So what we have done here, we have converted our Cartesian coordinates x, y to polar coordinates r and theta. How we have converted this? By assuming x as r cos theta, y as what? R sin theta, right? So from this what we can say? X square plus y square is equals to r square times cos square theta plus r square times, from this r square times cos square theta plus sin square theta, right? So finally your x square plus y square will be what? R square. Then we have found out our mod j, right? That is our determinant of del x upon del r, del x upon del theta, del y upon del r, and del y upon del theta, right? And this is giving us answer as what? R. So finally our double integral f of x comma y dx dy over a region R is converted into double integral over R f of r cos theta comma r sin theta mod j into dr d theta. But the value of mod j is what? R, right? So using this method we can convert our Cartesian coordinates to polar coordinates, right? So I hope you have understood throughout the session. Thank you for watching.